They asked to integrate 0 to infinity e power minus x square dx. When see the question seemed to be a gamma integral, but what is the difference between there? Gamma integral limit should be 0 to infinity, and we have x term x power n and e power minus ax into dx will come. What is the difference between these two questions? We have e power minus x squared. If there is no x term also, no problem, you can consider say x power 0. But what is extra? Here e power x squared, here e power x term only will come. And it's possible go directly gamma integral. Then if it's going substitution method also, when d equal to x square, if you take when differentiating dd by dx, here 2x will come. Then instead of x you have substitute root t, it takes as another long process. So if you want integral the sum, substitution method gamma integral or Bernoulli's multiple of two variable u into dv. So there also we e power x term is not possible, but e power minus x squared is there. If any multiply x power n or 2x is there, it is easy to follow the multiple of two variable also. So here what method are you going to follow? Just apply the property you are going to use here. So gamma n equal to 0 to infinity d power n minus 1 e power minus d into dd. So that property going to apply here. So before apply this property, now from this given question take d equal to x square. So when differentiating dd by dx equal to 2x. Now dd equal to 2x into dx. Now change the variable d into x, then you have to change the limit also. When x is the variable, the limit is 0 to infinity. 0 to infinity. Now instead of x, change the variable into d. Now substitute 0, 0 square also become a 0. Infinity square also become a infinity. So in d also have same limit 0 to infinity. Now from this question, take that question gamma n. Take the property gamma n equal to 0 to infinity. Now in the place of d, substitute x square because I assume d equal to x square. So x square the whole power n minus 1. Then e power minus t, substitute e power minus x square instead of dd, that value 2x into dx. 2x into dx. Now take 2 out of integral constant term. So gamma n equal to 2 into 0 to infinity x multiply 2 into n, 2n, then 2 into minus 1 minus 2. Here we have 2x is there, here x power 1 is there. When I add here it becomes plus 1. Then e term e power minus x squared into dx. Now gamma n equal to 2, 0 to infinity, 2 minus 1 will come. So x power 2n minus 1 e power minus x squared into dx. Now the same term bringing the like a question we have 0 to infinity e power minus x squared into dx. There is no x term. So but we have x term 2 power n minus 1. So instead of n substitute any one value, we need to eliminate the x term. So in this equation I go and substitute, because I use the word equation because gamma n equal to, now in the place of n substitute the value 1 by 2. Substitute put n equal to 1 by 2. So in gamma n also write gamma n. Instead of gamma n substitute 1 by 2 equal to 2 into 0 to infinity x power 2 into 1 by 2 minus 1 e power minus x square into dx. Now 2 to eliminated, x power 1 minus 1 0 will come. Now gamma 1 by 2 equal to 2 into 0 to infinity x power 0 e power minus x squared into dx. Now the gamma 1 by 2 value is root pi. This is a root pi. This is a gamma n is a root pi. Now bring it this side 2. Now bring the 2 this side, become a division 0 to infinity. X power 0 1 will come. Now we can write e power minus x squared into dx. So we want to find 0 to infinity v power minus x squared. That value is become a root pi by 2. This is the value of the given question. So 0 to infinity e power minus x squared dx equal to root pi by